Yes, I'll start out here talking about the lower trophic food web, and just kind of a quick overview of what I'll be talking about today. Kind of your standard lower food web stuff. We have spring total phosphorus and spring chlorophyll, zooplankton, mysis, diparia, mussels. Looking at some of the nearshore and offshore patterns that we saw in 2019, and then some seasonal patterns. I just want to highlight the spring total phosphorus, the spring chlorophyll, and the mysis. And those were three of the highest ranked indicators for understanding fish production in Lake Michigan in that lower trophic food report that came out a couple years ago. So just want to make sure and we highlight those because they were in that report. So starting out with one of those important indicators, we have the total phosphorus, and this is from the offshore in May, and it's from the Muskegon Grand Haven area. And you can see it's been pretty variable across time, going back to to 1983 even in this data set. But you can see for quite a while now, spring total phosphorus in the offshore has been pretty low, and 2019 was no different. It was still pretty low. Next, one of the other important indicators is the spring chlorophyll, and this is the May chlorophyll on a lake-wide basis. It's derived from satellites, and this is from the EPA, some of their data. And you can see that over, as we know, 2000s, the chlorophyll declined, and it's been pretty low ever since. And in this plot, you can see really 2018 through 19, chlorophyll has really not changed hardly at all in the offshore in the spring. And this really reflects what we all know, we've lost our spring bloom of chlorophyll. And the spring is really where we see our big changes. This is lake-wide monthly chlorophyll in a plot, satellite derived, again, provided by the EPA. And you can see back, in the late 90s, early 2000s, we still had that spring bloom, but now that's where we see our biggest changes in the spring. We see changes in other seasons, but really the spring is where we've seen our biggest changes. And this graphic from the EPA really nicely shows how the whole seasonal progression of chlorophyll has changed in the lake, and especially in the spring. So next we'll move from the offshore into the nearshore. The nearshore is a lot dirtier, a lot nastier to look at. In theory, mussels should have access to the whole water column throughout the year, but mussels in the nearshore can be really patchy, and so even though they're abundant, it's really hard to get a handle on what their effect is. We spent quite a bit of time this past year looking at some of our nearshore data. And there's a couple things I just want to point out here is first of all, it's thought that, and it seems that upwelling and tributary inputs help maintain the spring phosphorus and the chlorophyll in our nearshore areas. An example here is from Muskegon, some chlorophyll data, and you can see here May is still the period of the highest chlorophyll throughout the year in that nearshore site, and that's pretty consistent among the sites that we looked at, where we still have the highest chlorophyll and phosphorus is in May yet, and so that contrasts with the offshore. But that's not to say things haven't changed, but the changes we've seen aren't consistent across sites. So here we have on the bottom, we have some data from Grand Haven off the Grand River, which is a major source of nutrients for the whole lake, and then from the nearshore station off Mona Lake, which is just maybe 5 miles north of that Grand Haven station. In both of these, you can see May is the highest period of chlorophyll at these sites, but you can see we've had huge changes since the mid-90s at this Grand Haven site, where huge declines in the spring and summer chlorophyll and also phosphorus at that Grand Haven site. Whereas at the site just 5 miles north of there, almost no changes over the same period. So we have inconsistent changes across sites over time in the nearshore. So going to one of those indicator periods, again, spring total phosphorus, but this time for the near shore. And here we see, again, the trends that we see over time depend on location. So at a Muskegon nearshore site, we really don't see any consistent changes over time. And at that Grand Haven site, compared to the mid-90s, we see huge declines in the spring total phosphorus. And this is for May. And for 2019, at least for May, nothing incredibly remarkable about what was going on at either of those two nearshore sites. Next, the May nearshore chlorophyll, and for both those sites, and we see pretty much the same thing we saw with the phosphorus. We don't see any consistent changes over time at Muskegon. We see huge declines over time at the Grand Haven site, with nothing real remarkable in 2019 for either site. And these big changes at the Grand Haven site are notable, just considering the importance that the Grand River has for the overall nutrient load for the whole lake. So just to see how some of these trends, we looked at May, but just to kind of get an overall look for how chlorophyll and phosphorus behaved over the whole course of the year. And so this is data from a Muskegon offshore site and then the Muskegon nearshore site. And you can see, indeed, here, the Muskegon, we have this elevated chlorophyll and phosphorus in the spring and May, and that's actually the lowest chlorophyll that we would see at the offshore site. So what we talked about where the nearshore chlorophyll seems to be maintained in the spring compared to what's going on the offshore. I think it's interesting just how little difference there is between the surface mixed layer of the offshore and nearshore throughout much of the year between these two sites, though. Then to make things really interesting, we'll pull up that Grand Haven site. And we didn't see much of a change in 2019 during May at that Grand Haven site, but what we did see is that in our April sampling, we had just incredibly high total phosphorus and chlorophyll. And this really, 2019 was a year of really high runoff, really high flow. And you can see where we have quite a few, looks like episodes of inputs, even into late as December, of phosphorus coming into the lake. And we see a very high chlorophyll in April. I mean, this is some of the highest we have on record for our data set at this Grand Haven site, and it really remained elevated throughout the early summer. It is interesting, though, even at that site off Grand Haven, the chlorophyll is not that much different from the Muskegon offshore or nearshore site in the late summer and the fall. So we'll move into some of the zooplankton data. This is the lake-wide August zooplankton biomass going through 2018. This is from the EPA survey that happens in the summer. And you can see we've seen declines over time, but what's even more notable even than the declines are the changes in community composition, where we've seen declines in the amount of the community that's composed of Daphnia, and now the community is almost all calanoid copepods and limnocalanus. Limnocalanus are just a big calanoid copepod. So the calanoids reflect an oligotrophic system, which of course we have now in the offshore, and the Daphnia, and then the cyclopoids, which are never real abundant offshore, they reflect a more productive system. So our zooplankton community now really reflects the oligotrophic conditions we have in the lake. So next, to kind of put the zooplankton into kind of a seasonal perspective, on the top we have the 2019 zooplankton biomass by month, and then on the bottom, just the average zooplankton biomass for 2008 to 2018. Overall, zooplankton biomass, the annual mean was slightly lower in 2019 than what we'd seen on average. And that's really related to, in a large part, to lower biomass in the late summer, early fall here. And the big difference is lower Daphnia. So 2019 didn't appear to be a good year for Daphnia, and the Daphnia usually peaks in the late summer, early fall. It was interesting, though, in 2019, we saw quite a bit of cyclopoid copepods relative to what we'd see on average. Switching to the near shore, kind of a whole different story than what we saw on the offshore. Here, our annual mean in 2019 was much higher than what we see on average. And in large part, we just have really high zooplankton biomass in the summer in 2019, and especially high biomass of cyclopoid copepods, and maybe to a lesser degree bosmina. And bosmina are the main cladoceran offshore or near shore instead of Daphnia. We do have some sizable inputs from veligers that show up seasonally, usually in the early summer. It's important to note as well. But so just really interesting to see that we did see kind of a push in zooplankton biomass in 2019 at this site relative to what we'd see on average, and especially during the summer. Next, we'll look at the mysis biomass. This is from 2 sites off Muskegon that there's a long-term data set for. And you can see the numbers have gone up and down over time, but 2019 was definitely, we're on the definite, a low end of what we see. And I think it might be, for the offshore at least, the lowest numbers we have in this time series. And this really what we think is related to lower reproductive output. And you would think, given past trends, that they should be bouncing up given the low numbers of prey fish. So that relationship doesn't seem to hold anymore. And, it seems like reproductive capacity is lower now, and they aren't able to bounce back as they did maybe in the past. And mysis, if I forgot to mention, again, that was one of those important indicators. And certainly, you know, we've seen ups and downs over time, but it's definitely something that we need to keep an eye on, considering their importance as an indicator and because they're so low. Next, looking at diparia density, the main part of this plot is probably no different than what you've seen before. I just put it up for 2 reasons. One, you can see it goes on a 5-year progression. So this year, 2020, is supposed to be the year for the new lake-wide survey. Where that stands right now, I'm not sure. But 2020 is supposed to be the year for the lake-wide benthic survey. Also, if you look at this southern basin site, these 40-some sites get sampled every year. There's just one site right here in the deepest part of that southern basin where diparia have been collected in recent years. And in the samples that have occurred since 2015, their numbers declined every year until 2019. No diparia were found at that site. So there were no diparia found in that yearly southern basin survey this past year. Next, looking at the Dreissenid mussels, this isn't new data, but again, just to remind everyone that there are a lot of mussels in the lake, and also that we are due for our lake-wide survey in 2020, although we don't know where that stands right now. There is work that goes on looking at mussels every year, though, and this is just an example. Every year, 3 times a year, we collect mussels at the Muskegon stations. We see a few interesting trends here. It used to be that 45-meter zone was kind of the hot zone for mussels. We had the highest numbers there. Actually, now our numbers offshore are higher than in that kind of transitional depth zone. You see we've kind of ups and downs. Maybe the peak here at this 45 is lower than it was back in 2012. But interesting, at both these sites, the numbers have been declining over the last 3 years. The caveat for the offshore data is, even though the numbers are declining, those are really small mussels, and so they continue to grow, and so our biomass is probably still actually increasing in the offshore. And then looking at veligers, we've put a little bit more effort into looking at the veligers and the recruitment and how they relate to the recruitment of mussels. This is from those 3 sites off Muskegon from 15 meters out to 110 meters. It's really, I just thought interesting, just kind of that cycle that we see of ups and downs in veligers, and you see it most clearly at the 15 and the 45, a little bit less so at the offshore site. We're definitely on the downhill end of the curve at all three of these stations in terms of veliger density. So it will be interesting to see if we start going back up or if we stay at these lower levels going into the future. And just something that's really blows your mind is these are annual means, you know, across all 10 months that we sample. So you're talking annual means of, you know, these peaks, 75 to 100,000 mussels per square meter that are out there floating around that could settle out. So there's a lot of mussel capacity out there that could be settling out. So just to kind of summarize, I think 2019 was a real contrast between the nearshore and the offshore. In the offshore, it seemed to be status quo. The total phosphorus and the chlorophyll in the spring just didn't really change. Diparia remained low or even continued to decline. Mysis remained low and haven't responded to the low fish numbers. And zooplankton remain low and for the most part reflect an oligotrophic community. In the nearshore, we had a lot of runoff, we had a lot of rain, and we thought that might affect the lake, especially in areas where you have high tributary input. And so we saw some indications of high total phosphorus, high chlorophyll, especially in the early spring at that Grand Haven site, where we had just incredibly high phosphorus and chlorophyll in April. We also saw relatively high zooplankton, and especially cyclopoid copepods, which are reflective of a more productive zooplankton community at our Muskegon site during the summer. And then looking forward, I had these in the original talk. I left them here just, even though we don't know where we are due for the lake-wide mussel and diparia surveys, the benthic surveys this summer. I'm not sure where that is. And we had planned on more intensive work at looking at the veliger dynamics, their growth, their recruitment that ties to our mussel population. We're able to do the retrospective analysis with the data we have, but the intensive field work portion of that will probably be delayed till next year. So that is all I have.